Today let's do the problem convert a number to hexadecimal in C. So it's quite interesting to do this problem. We have done this in Python, but let's do this in C. And so what is the approach here? So the function, it gives you a function. Basically the problem is very simple. You're given a number and you're supposed to return the hexadecimal representation of this number, and if it is -1, you're basically, I think he's converting it to unsigned int, and then he just returns the hexadecimal representation of that number. So now let's do, how do we do that? So one thing you know is fundamental principle. Before we start coding even, what are we going to do is we will say, general idea is divide the number by 16 repeatedly. And collect all the reminders. Collect the remainders. This is the general idea behind this problem. So let's try this approach. So to collect the reminders, first thing is, let's start with a variable known as for the reminder, int r. Now we'll use, as we know, what are the hexadecimal digits. So for that we had a string array, an array which is basically all the hexadecimal numbers. So 0, 1, 2, 3, 4, actually 4, so 4, 5, 6, 7, 8, 9, and then you got A, B, C, D, E, and F. So that's your, these are all your hexadecimal digits. Now car star buff. Why do I need this variable? So I guess we'll need this variable because at some point we're gonna have to return, remember we have to return a car star. So this is your return variable. So let's call it return variable. And memory for this will be assigned later. And now why do we need head, and why are we initializing that? This is a global, because apparently the Leetcode doesn't start every problem from scratch, so you'll still have previous data. Then you got unsigned int q is your quotient. So let's start now. So first thing is boundary conditions. What are the boundary conditions here? You got to see if num is equal to 0. If num is equal to 0, you want to return, obviously you want to return only 0, right? So this is easy. Now if num is 1, if num less than 1, or actually, you know what we would do, because we have the unsigned int q, so we'll actually work on unsigned int q even though we are given int num. So what do? We'll say q equal to num, and so this is 1. And now let's start with the main crux of the main loop. What is the main loop, right? The main loop is, you are having a, so while q is, so we start with q and then say while q. So the way we are going to do is, we are going to say while q greater than 0, we continuously repeatedly divide it by 0. Say r equal to q mod 16, and then q equal to whatever is the quotient, so q to q 16, so remainder. And then like in Python we use the function div mod, but there is no div mod in C, so you have to do it in 2 steps. So r equal to remainder after dividing 16, and q is basically is, actually there is a mistake here, this is not remainder, this is the integer division. whatever is your numerator after the division by 16. So now now we have R and Q. All we do is we say add node front. This is a helper function we'll write soon, and we say head. This is the head of the linked list, and then we say string. This is this, we had a string of an array on the stack that we had initialized to all the hexadecimal digits. So we get the hexadecimal digits from R right away by indexing into that string R. So this is pretty much our while loop, and now we finally our return array buff, because remember we have to return char star a string. So we do a space for that, malloc 32 bytes. Okay, good. And then we say return, this is one more, return hex string, hex str, and then we say head. This time we don't have to, because we are not modifying the linked list, we are only collecting all the remainders. And because we have put the remainders in reverse order, because you see we were doing add node front, meaning every time a new remainder comes it goes to the head of the linked list. So we don't have to do a reverse or anything like that. We can simply just collect them all into buff, or we just need to know how to write add node front and hex string function, and with that we should be able to make at least step 1. And what are the step 2? So for that, let's write our 2 helper functions. And what are those helper functions? One is add node front and other is hex string, right? So we would start by writing add node front first. So first thing is, what is the node we are defining? We are defining node as node of the linked list as type def struct node and then char c. Each node has one hexadecimal digit of the number. So char data, let's say data, and then you have the next node in the list. So struct node is star next, and that's your basically node of the linked list. So that's this. Now let's write the function add node front. So add node front takes pointer to head, which itself is, if you think about it, what is head? Head is node star head, and it's global, so it's initialized to null automatically. You don't have to initialize. But anyway, you see head pointer to, anytime in C you want to modify a variable in the caller, you pass pointer to it. Since in this case already a pointer, so you pass pointer to pointer, and then you say char data. So that hexadecimal digit is added in the front. So let's do that. So how do we want to do that? We start by allocating a new node star new equal to malloc size of node. Now you see in real implementation you also need to check, in production you have to check the return value of malloc, but here for the sake of time we'll just assign new data equal to data and new next equal to the current head. So that way each new hexadecimal digit, each new remainder that we get, it gets stick in the front of the node, the linked list. So the least significant digit will be in the end of the list, so we don't have to, we can simply walk this list from head. So we say star head, okay, and then you say star head, new head is the latest point, the latest node that we got. So that is we got add node front. Now only thing we have to do is we have to write our helper function hexstr, hex string, and what is it returns a char star, but what is it, what are its argument? It takes the your linked list and char star, a buffer basically, str buff. So let's write that. So now node, we say node star temp equal to head, okay, and we say str buff equal to 0, null terminated. So the string that is to be returned char star is basically, if you think about it, it starts as a null terminated string and we keep writing it to it. So as we write into it, you see that how it gets formed actually, you see that. So you say while temp, now we are walking the linked list of these hexadecimal digits. So while temp, tmp, okay, so we say size type offset equal to strlen strbuff. Once we know what is the offset we'll be writing at, all we need to do is call sprintf library function, and we pass it the address of strbuff offset strbuff offset, okay. So that's your okay, and then what do we write into it? We write %c each character, each hexadecimal character. So that is temp data, right? Once we got this, we have to move to the next pointer, next node in the list, and in the end we need to say return strbuff. So we have made our string. So suppose if you had 26 as the digit that whose hexadecimal representation we want, we will get in the list, you say you will have, first you will have 1, then you will have a is for 10, because first time we got 10 as a reminder when 26 divided by 16. So let's see that. Let's try to run this. Okay, so we have issue here. What is the issue here? Okay, so we got an extra, I think we got an extra brace here. So let's see the run again. Okay, expected identifier before. Okay, so what is the issue? Let's see that. So we have num is finished here while q is finished here. Q greater than 0, not less than 0. Let's see that. Okay, now while, okay, let's see that. So this one num is, this brace is closed here. Did we make a mistake here? Q equal to num, okay, while q greater than 0, okay. We say r this at node front buff equal to malloc, okay, and then we say return. I think we still have extra. I think this, let's see that we had an extra actually. Okay, now we got here. So the main is good now, the 2 hex is good now. Now here he's saying that you got str buff equal to this, and he's saying strlen is argument 1 which is declared to never be null. Here null pointer passed as argument 1. Why null pointer passed as argument 1? So let's say the car star buff return var. Okay. Did we do a buff equal to malloc 32? Yes, we did. So then what is the problem? Did malloc return null? Which is declared never to be null. So why buff is being return var? Okay, return hex string head buff equal to malloc 32. Return hex string head buff. And here what did we do? We are node start temp equal to head. Oh, str buff we said. Oh, actually, you know what? We have to say str buff 0 equal to null. First character in the string, we are setting it that to null, not the whole thing. So there we go. It's actually accepted, and we can try to submit it. So again, let's summarize before we submit. What did we do actually? If you see the main function, the car start 2 hex, what do we say? We only had a boundary condition problem. Other is we converted the number that is integer that was passed to us. We assigned it to q. So if you pass -1, it will get converted to FFFF all. And then we worked on that unsigned thing. This is very important here. You see, we are working on an unsigned int, not on the num, which is integer. And then as we collect these remainders, we get their string representation, actually the character corresponding to the remainder. And then we just call add node front. And what is add node front is a trivial function, is adding a link, the node to a linked list front of the linked list. So that does it. And then in the end, because we have to return a char star, so even though buff the pointer is on the stack, we do a malloc on heap, which is global, and then we call hex string head and buff, which basically pretty much walks the list and collects these hexadecimal digits and then basically sticks them to str buff, which is another interesting piece where the trick here is to keep always adding in the buff at the location str buff offset. This is very important. So we always, what is the offset? Offset is str len str buff. So first time it will be 0. So the first character will go in the str buff at 0. And then the next time it will go to 1, 2, 3, and that is how. And it will be null terminated in the end. So that's why it's working now. Let's do a submit. You see it beats 100% of the submissions. So there we go. We have a return hexadecimal digits, convert a number to hexadecimal digit done in C, which is a little bit more interesting approach here because you get to understand some of the concepts about sprintf, how to convert how to collect bunch of hexadecimal digits as part of a char star, a string, using strbuff. I think this is something which is a little bit different in this case. So with that, I will have to say goodbye to you guys, and I'll see you next time for the next Leetcode problem. Bye bye.